Welcome to this video, where we are going to tackle an interesting problem. The problem we're addressing involves accessing the actual pointer values returned by C functions called strtypes. The goal is to verify the pointer values passed to and returned from a shared library function, specifically to test if strdup in C returns a new pointer to a different memory address. Now, let's dive into the solution that was proposed to address this problem. By using types.pointer, types.c_char as the return type, we ensure that the C pointer is retained instead of being converted to a Python string. This allows us to keep track of the actual pointer address returned by the C function. Additionally, setting the return type as ct.c_void_p provides us with a C address as a Python integer, which can then be cast to a more specific pointer type to access the data at that address. Continuing with the proposed solution, let's explore the code provided. The snippet demonstrates how to use types to access and verify the C addresses of pointers returned by C functions. By utilizing functions such as ct.addressIf and ct.cast, we can accurately examine and compare the addresses of the pointers, ensuring that the return pointer indeed points to a different memory location than the input pointer. This allows us to perform detailed testing and verification of the C function's behavior within our Python code. Moving ahead with the explanation of the final part of the solution, we see a practical demonstration of accessing and verifying C addresses through the provided code snippet. By leveraging types, functionalities, and the C function's return types, we can confidently validate the behavior of the C functions, ensuring that the pointers are correctly handled and pointing to distinct memory regions. In summary, we've explored a robust solution to the problem of accessing and verifying C pointer values returned by functions called strtypes. By utilizing specific return types and casting mechanisms, we can accurately track and compare the C addresses of pointers within our Python code. I hope you found this video useful, and if you did, don't forget to like, subscribe, and leave a comment below. See you in the next video.